Hello and welcome to another video. My name is Haroldas and today I want to talk about the solid principles. Solid principles have been created by Robert C. Martin, also known as Uncle Bob. Apparently he's also one of the creators of the Agile Manifesto. Essentially, solid principles are a set of best practices that are recommended when writing object-oriented programs. For this example, I've started off with a C# console app. So let's start with the single responsibility principle, which states that a class should only have one reason to change. In practice, this means that you should separate non-related functionality into separate classes. As an example, I've got this add2mailinglist method in the user class, and it has a try catch inside it. If there is an exception, the user class is responsible for doing its own logging, so this code breaks SRP principle. To fix this, create a new iLogger interface, add the logging methods, then add the iLogger as a private property to the user class, then add the logger to the user class constructor. In a real world scenario, we would set up dependency injection, but we can pretend that it is already set up for this example. Then replace the concrete logging method with the method from the interface, and now finally you can add the concrete implementation of the file logger. As you can see, now the user class is responsible for stuff related to user, and there's a separate file logger that performs the exception logging. Now this code follows the single responsibility principle. Next, the open-close principle, which states that a class should be open to extension but closed for modification. For this example, I am starting with another user class that has a user type enum and a getDiscount method. Notice how the discount method has an if-else statement which returns different values based on the user type. What would happen if you were to add more user types? You would need to keep adding the if-else statements and thus keep changing the user class. This is breaking the open-close principle. To fix this, get rid of the user type enum and then make the user class abstract. Also get rid of the concrete implementation in the getDiscount method and make it abstract. Then create separate classes for each of the user types, overriding the getDiscount methods with the concrete implementation specific to that user. And now this code satisfies the open-close principle, allowing you to add as many new different user types as you want without modifying the existing user class. The Liskov Substitution Principle states that you should be able to use the subtypes of a parent class without altering the correctness of the program. In practice, this ensures that subtypes have the same interface as the parent class. This principle was introduced by Barbara Liskov, the creator of CLU or CLU programming language. In C#, you can achieve this by either using interfaces or abstract classes. Here's some code that breaks this principle. We have a base user class and two subclasses where each one has a reset password method, but the guest users can't reset their passwords, so it throws an exception. To fix this, let's change the reset password method return type from void to bool. The idea being, if it managed to reset the password, it will return true, otherwise false. So now, even though guest users still can't reset their password, the method still works and doesn't break the program. The interface segregation principle states that you should have many client-specific interfaces instead of one general-purpose interface. This promotes a more flexible and reusable design by allowing clients to only implement methods that they need. As an example, I have another user class and an email sender interface with a bunch of methods. So now if I only want to use the send email method in my user class, I will need to implement all of these other methods, even though I only want to use that single one. To avoid this, create many client-specific interfaces. And now if I only want to use that single send email method, I don't have to implement all of the other ones. And lastly, we've got the Dependency Inversion Principle, which states that high-level modules should not depend on low-level modules. Both should depend on abstractions. This allows for more flexible and testable code by decoupling modules, making it easier to switch between implementations. As an example, I've got an email class and a notification class that depends on the email class, and this breaks the principle. To fix this, I created an iMessage service interface with the send message method. Now the email class can implement this interface, and instead of the notification class directly relying on the email class, it now relies on the iMessage service interface. Overall, following solid principles in code is not a requirement, but a guideline of how a well-designed object-oriented program should behave. It makes the code easier to test and understand. Like and subscribe if you liked the video. Thanks for watching and see you again in the next one.